All right, so today we're graphing square roots that have a vertical stretch in them, following up on the heels of the stuff we did yesterday. So I'm going to start this problem the same way I started the ones I did yesterday. I'm just going to see what happens when I plug in a couple numbers for x. So what if x is 0? That'd be 3 times the square root of 0. What's the square root of 0? 0. And 3 times 0 is 0. Okay, so if x is 0, that means y is also 0. So I have a point right here at 0, 0. So go ahead and plot that point at 0, 0. So again, notice that the normal square root graph starts at 0, 0. This graph starts at 0, 0. The starting point was unaffected. Where we go from there, though, that will be affected. All right, let's plug in 1 for x now. So we're going to do 3 times the square root of 1. Well, what is the square root of 1? 1. And 3 times 1 is? 3. So that means x is 1, y is 3. So that gives me the point 1, 3. Now notice what just happened. Normally, I would go over 1 and up 1 if it was just plain old square root of x. What it did is it went up 3 times as far. So instead of up 1, it went up 3. I multiplied the height, and only the height, by 3. I'm still going over the exact same amount. All right, now for the next one, this is where the square root graph was kind of its unique own little beast here. The next point, if I were just graphing the square root of x, remember, I wouldn't go over 2 because I don't know the square root of 2. It's some decimal. Instead, I would normally go over 4 and up 2, normally with square root of x, because the square root of 4 is 2. But in this case, I'm not going to do that. I'm not going to go up 2. Instead, because of the 3 being multiplied out front, I'm going to go up how far?
12.
What's 2 times 3?
6.
6. So I still went over 4, but then I went up 6. All right, and then thinking about that next point after that, normally if I'm graphing square root, after I go over 4, I go over 9. Because remember, I'm looking for the numbers I can actually take the square root of. The square root of 9 is 3, so normally I'd just be plotting a point there. That would be the normal, just plain old square root of x. But in this case, I'm not going to go up 3. Because remember, I have to multiply my up. I have to multiply my y by that number out front. So I got to multiply it by 3. So instead of going up 3, I'm going to go up 3 times 3, which is 9. So it goes over 9 and up 9, as it so happens. And those are all of them that fit on our graphing grid. So go ahead and draw your curve that goes through those points. So now we're going to see how it would apply with something like this. So go ahead and write down this equation, and then we'll do it together. We still start this one by doing our movements. We still shift it first. Just like we started by shifting our absolute values and our lines yesterday, we start by doing the shifts. So this plus 8 up here, which way does the plus 8 move it? Up, down, left, or right?
Left.
It moves it left, yes. Because it's inside with the x, so that tells me to move it in the x direction. And plus means left in that case. So I'm going to go left 8. And the minus 3, which way does that tell me to move?
Down.
Down, yep. So the minus 3 tells me to go down 3. So then, my very first point then is going to be left 8, down 3. The 2, notice, did not affect that in any way, shape, or form. Now we have to deal with the 2 though, because the 2 does change where we go from that starting point. It doesn't change where the starting point is, but it changes where we go from it. Alright, so from here, normally from my starting point, I would go over 1 and up 1. Normally. In this case, however, I'm going to go over 1 and up how far?
2.
2, yep, because I'm going up twice as far. So 1 times 2 is 2. That's how I know to go up 2 there. All right, next. The next point I would normally plot after plotting over 1 up 1 would be over 4 and up 2. All right, so in this case then, instead of over 4 up 2, I'm going to go over 4 and up how far?
8. No.
I'm multiplying my height by 2. So 2, my normal 2 gets multiplied by 2. It's 4. So I end up going over 4 and up 4, as it so happens. All right. So then I've done my over 1. I've done the over 4. How far over do I go next?
Over 9 up 6.
It's over 9 next. Yep. Because that's the next number I can actually take the square root of. I don't know square roots in between there. They're all decimals. So normally it would be over 9 and up 3 normally. In this case, though, it's going to be over 9 and up how far?
6.
6. Because the normal up 3 gets multiplied by 2, so that's how we get the 6 out of that. And on your graphing grids, we can actually fit one more point on there. After we go over 9, how far over would we go? Normally it would be over 9 and then over 16. Because I know what the square root of 16 is. What's the square root of 16? It's 4. So normally I'd do that. In this case though, I'm not going to go up 4. Because of the 2, remember, I have to multiply the up, and only the up, by 2. So what's 4 times 2?
4 times 2 is 8.
8. Yep, so I'm going to go over 16 and up 8. To get that last point. And so then go ahead and draw on the curve that goes through those points because we're up against the edge of the graphing grid. And that's as good as it gets.